This is introduction to Darshan. And Darshan is the thing we want to kind of get across as what to do when you don't know what to do. This is your starting point. You don't know what your I/O is like. You don't know if you have a problem or where the problem is. This is kind of your starting point to understand your I/O. So the kind of questions you might have as a user of one of these systems is, you know your runtime, right? You're requesting job allocations and you're getting periods of time to run your code, and you might wonder, well, how much of that time am I really spending doing I/O versus doing my math, doing my calculations? And does it get better or worse or the same as I run bigger jobs? So you get access to a bigger system. Maybe you want to run bigger and bigger simulations. Is the I/O time being more of a problem, or is it okay? Does it change if you go to different platforms? And suppose you do suspect an I/O problem or just want your I/O to be better, how do you know where to start? What's the most important thing you could begin with to improve your I/O? Because you could spend a lot of time tuning, but some tuning is more impactful than other tunings. So we're going to talk about Darshan to use as a starting point. And the presentation right now is just an introduction. This is how to use the tool. We'll refer to it more in the day because it's a good thing to use to show examples about what's happening in an application so you can kind of see the impact of things. And we'll later do some more kind of exercises with Darshan where we see a problem, we fix a problem, or consider alternatives to it. But this is just how to use it, how to get started. So what is Darshan? It's a scalable characterization tool, that's what we call it. And what it tries to do is capture a kind of compact summary of what your application did. So it's not every single little I/O detail. It has a lot of I/O detail, but it's not everything. But in exchange for not quite capturing everything, it's very lightweight. So in fact, if you log on to ALCF or a lot of the DOE facilities and just run your code, Darshan's probably there already. It's probably already capturing information. You just need to know how to tap into it. So it's deployed at a lot of places. If it's not deployed at your favorite site, it's not hard to do. In fact, you can install it as a user. You don't have to have an administrator do this for you. And I won't cover how to install it because that's not of interest to everyone, but we can help you with that tonight if you're interested in it. It's easy to use. Once you've got Darshan set up, you don't change your application. You don't really have to opt into it or anything. You just run your code and leave it on, and it does what it's going to do. The important step is once your application has run, you have a summary, and the question is, what do you do with that summary then? How do you look at it to understand what's going on? And that's a lot of what we'll talk about this morning. And so when you look at this, you'll get some histograms. What kind of data access did you do? What types of operations did you do? How many did you do? How much time did you spend? That kind of stuff. So Darshan is primarily for MPI applications. So I apologize, some of you are probably not using MPI. Darshan probably won't quite work for you just yet. We can talk about that a little bit. But assuming you have an MPI application, it gathers statistics at each rank of your application and stores it in kind of compact memory. It takes a tiny bit of memory on each process and keeps some light statistics there. When your application shuts down, Darshan collects all those statistics from all of your processes and mushes it together, filters out some things that you might not need. It compresses what's left and writes it out into a little log file. And then that log file, you can come back after your job completes and look at it and see what happened, learn a little bit about your I/O. And the starting point, we got a handful of different tools for kind of poking at this log information, but the best starting point is a tool that will generate a PDF with kind of a bunch of different graphs and charts and tables and things that you can look at to see what happened. And that summary PDF will work on any Darshan log, so anyone can do this with something that's been instrumented with Darshan. And we'll talk a little bit about what that looks like in a minute. So I'll walk through kind of using Darshan, and I'm going to talk about Theta because that's what we have a reservation on today, but this should be similar on a lot of platforms. But on Theta, Darshan's loaded automatically. It's already there. You don't have to do anything extra to turn it on. But you can double check this to make sure it's there. If you run the module list command, you'll see a list of all the software that's loaded in your environment. Darshan should be on the list. If it's not, just do a module load Darshan and it'll add it to your environment, and you've got it there. That's kind of all you have to do to get it started. Once Darshan's in your environment, or assuming it's already there, just compile and run your application. That's kind of all you do to get Darshan instrumentation. There's some fine print in the blue down here. There's a caveat, which is that if your application doesn't call MPI finalize for any reason, you won't get a Darshan log, because that's the point where it collects this data and writes it out. So reasons you might not call MPI finalize are if you deliberately run to wall time, until your job runs out of time, or if your job crashes, or if you just forgot to call MPI finalize. So if you think Darshan's turned on and you're not getting a log, that's the first thing to check. If you don't normally call MPI finalize, then you may need to do a special run that does, just so you can get your log. But otherwise, it's supposed to be automatic. So once you've done that, you've got to find your log, you've run your job. This is, it'll sound like a broken record, but you got to look at your facility documentation again and see where the log files for Darshan are stored. I've got the path for Theta here. You don't have to write it down. You can look at the ALCF webpage or refer to these slides, but you go to this one central location. That's where all the Darshan logs go for everyone when their job's complete. And you won't be able to read other people's logs, just yours. But you go into a subdirectory in there, split up by year, month, and day, and look for your log. I'll give you a tip here. Be aware of what time zone your system is in. ALCF in particular uses Greenwich Mean Time, which means that at 7 p.m. tonight, it will be tomorrow on Theta. So if you go looking in today's log directory and you don't see your stuff, try the next day. Maybe it's there. The file name, once you get the right directory, it's going to have your username. So my username is Carns. It's in red there. It'll have your application binary name. So this was a program called Warp Drive A. It has your job ID. So if you remember your job ID from your submission, you can find it by that. And then there's a string of nonsense and a .darshan extension. So you find that log that you're interested in, you copy it into your home directory or somewhere else where you can kind of play with it yourself and look at what's going on. Yes?
For how long are the Darshan files kept?
Essentially forever. So as long as the machine is still up, the logs will still be there. The next thing, so you found your log, you've copied it somewhere, and you want to generate a summary. The one-step piece of this is the second thing highlighted in blue. Is run a tool called Darshan Job Summary. And this is the thing that will produce a PDF that kind of captures what happened in that log file. There's a little bit of a quirk on Theta. There's a bug on Theta at the moment. For this tool to work, you have to run module load tech live first. I apologize, this is a little bit weird. In the hands-on examples, if you run the hands-on examples and follow the instructions, there's a setup step at the beginning of the hands-on that does this for you. So if you're just doing the hands-on examples, you don't have to do this tech live thing, but you need to if you're generally doing this on Theta. Other systems, you don't do this. They're fine. But anyway, you run job summary. It produces a PDF that's highlighted at the bottom. Has the same name as the log file you started with, just with the .pdf on the end. And it spits out a few things along the way that you might want to glance at. This is also in the summary, so you don't need to be careful to save that or anything. But it tells you how many bytes you accessed and how much time Darshan thinks you spent doing I/O. So this example that I'm showing here spent 20 seconds doing file access. And what do you get? This is the PDF. Don't worry about reading every little word on there. I'll walk you through some of the important parts you need to know. But there's actually, I think, 3 pages in this that you can flip through that gets a little bit deeper into I/O as you flip through the pages. And I think I have this in a later slide, but I'll go ahead and mention it now. It's not crucial that you understand this whole summary. There's some simple things that I'll show you how to understand, but even if you look at it and it's baffling, you don't understand why something is the way it is, or you're not sure what a metric means, is still a good conversation starter when you go to an I/O expert or your support or your catalyst or whoever and say, I think something's weird about my I/O. I'm not happy about this. I'm not sure what's wrong. You can go and tell them that anytime, right? But if that's all you tell them, then there's going to be a long conversation to get to the bottom of what's happening. If you go to them with that same comment and give them this PDF file too, then you're both on the same page immediately. They can look at this and say, okay, I see you're doing this and this. So it's a good kind of conversation starter and a good way to get on the same page about your I/O behavior. So the very tip top of the PDF is just going to have a little summary. It has nothing to do with I/O. Here's your job ID, your user ID, the date, how many processes you used, how long it ran. So this is a super heavy duty job. It ran for 4 seconds. Yours probably run a little longer than 4 seconds, I don't know. But if you go just below that, there's kind of the headline summary of your I/O. And this is how many bytes you moved, reading or writing, and how fast it went. These are estimates because measuring I/O time is kind of a subtle art, and Darshan does the best it can without any knowledge of your application. So in this case, we accessed about 80 megabytes with MPI/O, and it got 8 gigabytes per second. And depending on what interfaces you use, you may get some different summaries here. So there's 2 in this example. There's one for MPI/O, and there's one for standard I/O. Standard I/O is what we call kind of the text functions like fopen, printf, fread, those kind of things. And there's already kind of a cautionary tale here. You'll see that the second one, well, it's really slow. It's only 3 megabytes per second. You can beat that on your cell phone. But that's not actually bad because it's only a tiny bit of data. It's 0.1 megabytes. So it didn't move enough data to get performance really up and running of this big storage system. So that was probably just a configuration file in this job. So that's the key is I/O performance only matters if you're doing enough I/O for it to be significant. The next thing, if you go down, I always point people at this big pink-looking graph on the left. This tells you what percentage of your runtime each process spent doing I/O on average. So this is a good first thing to look at because it's often the indicator of whether you have an I/O problem that you should be concerned about or not. The sort of fuchsia color here is things that were not I/O. Darshan doesn't look at anything else, so you could be doing anything with that time, but we assume it's compute or communication or whatever. The red and green and blue is time that was spent reading, writing, and accessing metadata. So this particular example, most of its I/O was with MPI/O, and it spent close to 20% of its runtime accessing data. So if you are looking at this and you see the I/O is really high, that's probably not what you want. You want to be calculating more, so it would be a good idea to try and push that down. If you look at this and you think you have an I/O problem, maybe you do. Maybe you're not doing I/O well, but it's only a fraction of your runtime, and you're getting all the data you want. Then, maybe you should turn to some other things besides I/O as your first kind of crack at getting more productivity. The second graph over there just shows you sort of some key functions you may have called and how many times you called them. So this application called read and write about 4,000 times in total, and it called open a few times. It called seek. That's the thing that lets you jump around in a file. Yep.
For the plot on the left, is there corresponding information about the standard deviation average times?
There is not. So this PDF, it really is just a summary. So it kind of, yeah. Unfortunately, we don't have a tool that shows that kind of stuff, so you'd have to dig into the log and pull that out yourself. But you can see a few things jump out on here sometimes. You may see some surprises. So reads and writes are unavoidable. That's how you access your data, right? But if you're doing things like fsync or stat or open as many times or more than you're doing I/O, those are functions that you also have to call, but they're not productively moving data back and forth. They're kind of setting things up. So we call those metadata operations. If you're doing more metadata operations than I/O operations, then you've probably got something you can fix. The next thing is a histogram of access sizes. So when you are doing reads and writes, how big are they? If you recall from the first presentation this morning, parallel file systems do better with big operations than they do with small operations. So if you're on the left side of this graph, all your accesses are 0 to 100 bytes, then you're going to have a bad time. It's just not great at that. If your access sizes are more towards the middle or right-hand side of the graph, you're doing well. So that's kind of an easy thing to look for, is just how big are your accesses and can you improve that. And then jumping down on the page, down at the bottom, there's a summary of file counts. So how many files did you actually open? And did you create them? Did you read them? Did you write them? And how big were they on average and how big were they maximum? So this is another case where we could probably get some more variance information, but we don't have that here. In this case, every file it opened was 16 megabytes. And flipping over to the next page, there's something that can be enlightening to look at sometimes. Is we call this the time span graphs. They're like a timeline. The x-axis is, starts at 0 with when your application started, and it goes up through seconds or minutes or hours for however long your application ran. And the y-axis are your ranks, however many MPI ranks you had. And this shows the span of time that each of those ranks was doing I/O. So there's one for reads, there's one for writes. So you can see if the I/O is kind of scattered through your execution time, or maybe it's all at the end, or maybe it's all at the beginning. There's nothing good or bad about any of those. It just might be helpful to understand where this is happening and see if there's any patterns you didn't expect. And that's kind of where the easily interpretable graphs end. If you want to dig in more, there's more graphs that I'm not going to walk through here. And there's also a tool called Darshan parser, and this will take a log file and just spit out an ASCII text table of everything that's in it. And if you're bold, you can look at that and stare at it like the Matrix and learn something, or you can grep through it. There's things you can do, but that's kind of that's where you're going to get to if there's something that isn't in these graphs that you want to find out a lot of times. So I've got some kind of power tips and tricks for getting a little more out of Darshan, but I'll pause there for a minute. Does anyone have any questions about the sort of things that Darshan does, or how to get started with it? All right. So these are, you usually begin with that. Sometimes you look at Darshan and it's not telling you what you want. There's a few things you can do to wring more information out of it. I'll tell you about a few of them. So one thing that might happen is, it's often a good thing if your application is accessing a shared file. By shared file, I mean one file that all your ranks are opening and closing instead of each having their own file. If you do that, Darshan, to save space, will collapse that information about that file into one record. It won't keep up with, rank 5 did this, rank 32 did this. It's going to say you had one shared file and this is what happened to it. And so if you look at those timelines I was just talking about, they might look like this. The top one is each rank doing, is that reads or writes? I don't remember. Well, the point is the top two are supposed to be the rank information, what each rank was doing. The bottom one is what all the ranks were doing on a shared file. And so in this example, it's not very enlightening because the span of time for which that shared file was written was all the way from the beginning to all the way to the end. And then there's a stretch of time where there was some reading going on too. But you don't know what's really going on in there, which ranks were doing the most work. Was it balanced? Was it skewed? That sort of thing. So you might look at this and say, boy, I really wish it wasn't collapsed into a shared file thing. I wish I could tell what all of my processes were doing. So you can do that. We just don't turn it on by default. The way you do this is just in your job script, you add an environment variable called Darshan disable shared reduction. And this instructs Darshan to say, if you see a shared file access where everybody's touching the same file, don't collapse it into one summary. Keep separate information for each rank in the application. So if you do that and run your job again and look at the log file, the same tools work on it. It's not a fundamentally different log file in any way. But instead of treating that as a single shared file with one stretch of time, it'll break it down by rank like this. So you might be able to see some interesting things about maybe there's one rank that's hanging on to IO for a long time and the other ones are finishing quick, or maybe the time is spread out differently than you thought. So, you don't necessarily need to start with this, but if you get into that situation where you're missing some detail in the shared files, this is one way to address that. Second thing I'll tell you about, suppose you do that and it's still not enough information. You're seeing this summarization of what happened. You're seeing some stretches of time that I/O happened, how much time I/O is, and you're like, I really just don't get it. This doesn't make sense. Where are these particular accesses that I know my application is doing? You can take Darshan and turn it into a tracing tool. It's not, you don't have to install anything else to get this or do anything different in your application. What you do is just go into your job script and set a different environment variable called dxt enable IO trace. And this tells Darshan that I'm getting serious here. I don't just want a summary. I want you to tell me everything that happened, and Darshan will capture that. So you have a tool. I gave an example of a tool here called Darshan DXT parser, and it will take a log that has this tracing turned on and spit out every single IO operation that happened from every rank, every offset, when it started, when it ended. And on a lot of storage systems, it can tell you also what storage server it accessed, so you can tell how it's using the file system resources available to it. So you can go and literally find every read and write access and see when it happened and how long it took. That's a lot of information to look at in text format, but we have another summary tool you can run called DXT Analyzer. DXT Analyzer will take the data from a tracing-enabled Darshan log and turn it into something like this. So it's the same format as those time span graphs that I was talking about earlier. We have time on one axis and MPI ranks on the other, but it's much more detailed. Every single read and every single write will be plotted on here. And so you might be able to see some more detailed patterns. So where before there was a stretch of time and it said, well, some reads happened in this time span, you'll get a dot for every one. And maybe you can see some funny patterns. So you can see obviously a regular pattern here, and you can see that there are two special ranks, the first and the last one, that were doing something different from the other ones. Maybe you knew that, maybe you didn't, but this is often kind of interesting to see if it looks like the pattern you thought you were generating. So just to kind of recap Darshan, we've gone through maybe more detail than you wanted. But the key thing is this is here, it's easy to use, you just gotta look at the log when you're done. And the main reason I went through this stuff wasn't to try and get you to memorize all these finer details of Darshan usage, but just to make you aware of what it can do. So if you have an I/O problem, you can come back and look at these slides and see what some ideas are. And the takeaways from this, we've got tools available. Darshan is not the only one. It's just kind of one of the more widely used ones that we talk about and use to kind of share information. It's probably already instrumenting your application on DOE systems at least. If it's not, we can help you get it going, hopefully. And there's documentation and, more importantly, support resources at your site that can help you interpret what you see there. And Darshan is an actively maintained, supported, updated tool. And just to give you an idea of things that will be coming in the future, so we're always updating the new HPC systems. So when the next one comes out, we'll have Darshan ready for it. We try to keep it operational on all the big platforms. We're currently, like literally this week, working on how to make Darshan work for non-MPI applications. So if you have some other programming model or something that doesn't use MPI under the covers, there's some hope that you can get the same kind of information. It's technically possible. We're just cleaning it up and getting it into something that can be deployed. And then last, we're working on ways to get information out of applications even if they crash. So they don't call MPI finalized. How can we still pull some information out and see what the I/O was like before that point? And I'll talk a little bit about hands-on exercises. If you go again to that link in the top corner, we've got some sections in there. If you look at the documentation about different topics that you can dig into, there's 3 things in the Darshan section. There's one that's called Hello World. It's just as you might expect, it's just running a program and looking for the log and trying to see if you can spot some information about it. There's two other ones after that called warp drive and fidget spinner. And both of these are kind of imaginary applications. There's an A and a B version of each. And the idea is that you run both versions, so warp drive A and warp drive B, and look at the logs. I can guarantee you, even with one run, I know I was talking about variance earlier, but these are different enough that one will be much faster than the other. And they're doing the same thing. Effectively, they're both doing the same amount of I/O and trying to accomplish the same thing, but either A or B has done it much better than the other one has. And so the idea is to look at the Darshan log and see if you can understand why they're different and what the change is that you would do to get in the faster regime. You can talk to us about these if you want to try them out. Actually, I guess the other thing I should say is those last two, I've told you how to use the tools, but I haven't told you the tuning principles. We'll get to that a little bit later. So those second two might make more sense after a little later in the day when you've heard kind of what are the things you should do to get your I/O fast. And so that's it for the introduction to Darshan material. Have any questions about that?
I'm a little curious about the development process for this. Is it file system agnostic, or do you have to tailor it to each individual?
All right, so the primary pieces of Darshan are file system agnostic. So the reason is because it links onto your application and watches what your application is doing and doesn't pay attention to what the file system is doing. So we're kind of interpreting from the application's perspective. There are some exceptions though. Darshan is actually a modular tool, so there's different pieces of it that could be active depending on what system you're on. So for example, in the trace example I showed, it connected your accesses to particular file servers. That's because there's a module on there that understands Lustre. So if you happen to be on a Lustre system, the Lustre module will wake up and gather some extra information. There's modules that will tell you things on the Blue Jeans system about the general environment. There's a few other odds and ends. So there are parts that are tailored, but we try to keep the core where it'll work anywhere.
What's included in beyond MPI?
Well, anything. I mean, I guess the things that we most commonly get questions about are things in bioinformatics that haven't been parallelized and you're just running a bunch of things, or things in deep learning, that kind of stuff. So I don't know, Glenn, what kind of people are interested in that at NERSC?
TensorFlow. So if you're doing a multi-node TensorFlow, this version of Darshan will be able to tell you what it's doing.
Yeah, so the reason that's an odd question for me is that Argonne, the systems encourage big jobs, so they're almost all MPI, but other facilities will let you run smaller, kind of capacity jobs. So.
Are there ever circumstances where you recommend that people do not load Darshan for performance reasons?
No, we do not. You may have someone from support recommend that to try in case it's a problem, but part of the Darshan maintenance process and kind of release process is that we do performance regression testing on platforms when we put it out. And honestly, even for the biggest jobs we can run on the systems, the most Darshan is going to add is going to be at the end of the job, and it'll be a few seconds. So it doesn't have much ongoing overhead, but then at the end it pays the cost of gathering this data. So for the most part, you're not going to notice it. It doesn't interfere with calculations.